right, just gonna let everything start. If you're in the chat of a particular thing, drop a comment, let me know that you can see me. I think I got everything set up. Okay. Awesome. Thank you, Mr. Certainly, for checking my stream. I like to get going just a couple minutes early to make sure everything gets going, and it took me longer to realize that I had like muted the video of my webcam than it probably should have. Okay. Hi, Anything Kid 123, and hi Simon Thomas. Thanks for watching. Yeah, I think Anything Kid's excited for the ESP32-S2 Feather. I think Unexpected Maker is going to be the first person to come out with one. Hi, Ian. But we'll support that with CircuitPython for sure. Basically, we put the work in to get a particular chip working in CircuitPython, and then different boards are pretty easy to support. We'll talk about that today. That's one thing I want to cover. Oh, I can go to just the camera. All right, so YouTube's up. I was looking. Just wait a couple more minutes. I think we usually get comments from Periscope and Twitch as well. It looks like they should be live. Everything looks okay. I've been updating OBS because, you know, nothing could ever go wrong with that. OBS is the Open Broadcast Studio. All right. John Park says live on Twitch. Drew the Ogre says Twitch is live. AnyRock89 says Twitch is up as well. Dennis says hi. Mark says chill with cat. Johnny Bergdahl says hi Scott, audio seems a bit low. I can try to move it closer to my face and get my radio voice on. Mr. Certainly says stream is live. This comment was pre-recorded. Andres Leon says howdy, can you talk about the ESP32's nearby detection? Detecting when another ESP32 is near. Unfortunately, I don't know anything about that. Yeah, sorry. If you want to talk about contact tracing, I could talk about that, but I don't know anything about the ESP32's nearby detection specifically. We could look in the data sheet and see if anything's there. Mark has you can see it in the stream too, an icon of water on the keyboard. I do have, as always, my glass of water, and behind me there's a second glass in case I either drink or spill the first one. Geek Guy, welcome for my first time joining my live stream. Glad you could make it. For those of you who don't know, I definitely spilled water on my keyboard because I have a split keyboard. I have one of the Keyboardio ones, and I knocked. I shouldn't do the motion. I knocked my glass of water on one of the halves of the split keyboard. All right, I think we're going, and I'm doing just a little more prep. I wanted to find on the blog they always have pictures of the day. I guess that's what these made in New York City posts are. Because I just wanted to start by talking about that. There should be an April 30th one. Oh yeah, you can't see my screen. Don't worry, I'll switch it. All right. I remembered I left my Wi-Fi on, so hopefully it's using the wired network, which is also connected. Okay. Andres says maybe it's called presence detection. Yeah, we'll have the data sheet open later. Just remind me of that, and we can see, or I could just Google it. I'm gonna Rod says morning from Australia. Thanks for getting up, Rod, and joining me. I'm glad to see you. Okay, I'm gonna switch to the offline just because I like to have that as my mark. I stole that from Peter from 1Bit Squared. Likes to do that too. So we'll do this. Hello, everyone. Welcome to the Deep Dive with Scott. I've started doing these every Friday afternoon, which is, I'm in Seattle, so it's just after 2 p.m. in the afternoon here. We're going to go into a deep dive on some CircuitPython ESP32-S2 stuff today. I did an unboxing for DigiKey last week, and I was hoping that I would receive an Oshpark order that I made. It's coming today, but it hasn't arrived yet, so we won't be doing that. Nothing on the overhead today. The general plan, or I've started doing this stream regularly at 2 p.m. on Fridays, so expect to see this pretty regularly, I think. The plan for today is I want to talk briefly about how Adafruit and another company are doing with the pandemic happening. Spoilers if you recognize this shirt. And then I want to recap kind of what my week was, and then we'll do some ESP32-S2 work. And Andres also asked about some of the ESP's presence detection, which I don't know much about, but we could totally take 10 minutes and Google and see what we can find about it. So with that, let me switch to my screen. First and foremost, I'm paid by Adafruit to work on CircuitPython. That's been true for almost 4 years now. The project's getting older and older and maturing, which is awesome. And Adafruit is not currently manufacturing or creating kind of their normal products, their normal maker products. They're only creating products for that are pandemic related. So if there's people prototyping a ventilator with Adafruit parts, like we might manufacture and ship that stuff. They've also been doing PPE things as well. If you want to know what's going on with Adafruit, there's this Adafruit Chronicles tag that Phil puts up, and they're pictures kind of from that day. So we can just see here. Geeks Guy says, I have an item on my calendar to remind me about your stream. Great. Good. That's a great idea. I almost forgot. I got absorbed into a blog post that we'll see shortly. So yeah, I just wanted to encourage everybody realize that lots of small businesses are having trouble right now. And fortunately, Adafruit was relatively well prepared, and they had a cushion so they could keep paying both me as a contractor and all their proper employees. They did also get a PPP loan, which helps put some gas in the tank, as Phil has said. But remember that tank is, continually being drained while they're not necessarily selling as much stuff as they would otherwise. So keep that in mind. If you're able to support, if you're fortunate enough, like myself, to have an income still, please check out Adafruit's stuff. You can buy Adafruit products from DigiKey still if it's in stock. DigiKey's been a huge help as well. And you can also buy gift certificates that never expire. So you can always kind of pre-buy stuff from Adafruit in the future. And you can also do IO subscriptions are still available as well. So if you want to support Adafruit, that's a great way to do it. And they pay me. So, and they pay me and they're paying everybody else. So that's important to note. The other company I wanted to talk about, and maybe I'm spoiling it here, is actually Pololu. I don't know how many of you follow them. I bought a shirt from them. They're a company out of Nevada. They're really big into robotics, and I actually kind of first found them, I think, when I was doing drone stuff prior to joining Adafruit. They have really good voltage regulator breakouts that it was pretty common to see on drones and things. So they weren't able to have quite as much cushion as Adafruit was. They did get a PPP loan as well, but I would also encourage you to just go to Pololu. They are shipping orders. They shipped this t-shirt and I got it. So if you like open source hardware and robotics, there's an interesting post here about what their future will be and how their lens on open source is changing. So that's cool, and I want to participate in that some more. They again, they got a PPP loan, but they're being very public on their blog. So um, they're a cool company, and I suggest folks take a look at them and see if there's stuff there that you could buy to help them out as well. Um, yeah, Ian says Pololu motor drivers. Yeah, lots of robotic stuff. I looked through it and I was like looking for like microcontroller boards that could run CircuitPython, and there weren't actually that many, which is something I'd love to work with them on. Um, but there's all sorts of cool robotic stuff that it's not definitely not my specialty. But if you're into that, please support Pololu as one of the folks that they're still around and they're still trying to push through. Philip says Lady Adafruit and her significant other are some of the best people you will ever meet. Yeah, definitely. Yeah. Phil and Lamore are awesome, and they work so hard. They worked hard before the pandemic, and now they're working even harder. It's just incredible, and they're doing that because they want to make sure that everybody still gets paid. So keep that in mind. And that's it for Pololu. So the next thing I want to talk about, and I talked about this. This is a random thing that I don't need. Geek Guy says Adafruit is awesome and how they take care of their people, including contractors and service providers. Pololu is another great company. Yeah, cool. All right. Thanks for that, Geek Guy. And since Andres was talking about presence detection, and it looks like I actually have, this is the module page open, but I thought I had the data sheet as well. Maybe not. We could take a look at that. I don't know. Can you tell this is like the browser that I've had for all of our streams? Yeah, I thought I had the data sheet. Geek Guy says Pololu has some great chassis kits as well. All right, so let's just see if, I don't know. I think, Andres, you're talking about maybe the regular ESP32, which I don't know, but let's just see. I haven't done much work at that. It doesn't look like there's any. Yeah, it's probably ESP32 because I don't think the S2 has Bluetooth, which is probably what presence detection is using. I can just take a look. BLE presence detector. Yeah, this is, I've been following a lot of the contact tracing stuff, and this is one of the topics that seems to get a lot of attention, is using Bluetooth, figuring out how far apart people are. I think it's a really hard problem. And so it's kind of one of those things where I'm just like, I don't really know what to do. I don't think it's solved by any means. All right, so sorry I don't have more information on that, but again, I can talk contact tracing if you want. I've been following the Apple Google stuff, but for actual presence detection, I don't know anything. Okay, so the first thing, I wanted to kind of do two things on the stream today in the deep dive. The first thing I want to do is I want to just recap kind of what I did in the last week regarding ESP32-S2 support in CircuitPython, kind of like bridging the gap between the stream last week and today. As you know, it's kind of been me saying, I'm working on this other thing and it's taking all my time. I was working on adding lower power support for CircuitPython. And the challenging bit was that our internal timekeeping for like time monotonic was all done, and sleep was all done using SysTick, which is a built-in timer to the CPU. And that is really bad because when you sleep, even in the lightest sleep, you idle the CPU by not giving it a clock signal, which means that timer no longer runs. And so all your timing would be off if you use that. And so this PR was giant, and it was all about moving all of our ports off of the internal timer onto the real-time clock or real-time counter, which most things have. It's usually in a separate power domain, so you can actually, it runs kind of almost always, unless it's like completely shut down. So this PR that was merged yesterday, which is the exciting bit, is checked in, and it's a foundation for. Oh, sorry. It's a foundation for doing more low power optimizations in CircuitPython in the future. Are there chats in Twitch that I'm missing? Because it seemed like it was a little bit jerky, but definitely seeing the YouTube one still. Okay, so the big news for ESP32 is the fact that I should be able to devote more time to it in the coming weeks, because the big change that I was finishing up is now checked in. There may be some follow-ups of that, but they shouldn't be anywhere near the size of that individual change. So where we left off was the linker. We got to the linking stage. So we talked about the 3 stages. Did I call it 3? So pre-processing, compiling, and linking. And that third, that we got through the first 2 stages, and then the third stage we were having trouble, and the linker was straight up crashing. 2 folks helped me out after the stream, both Mark and Ivan. Really helped out, and Ivan found that if we removed the GC sections portion, it would stop crashing. And then I was talking with Mark. He worked ahead and like got it better, made some improvements. Hi, David. Mark like kind of worked ahead of me, and so what I did yesterday was I actually went through the changes that Mark had made and kind of ported them into my stuff, along with moving my branch onto the latest master as well. So, hi, Mamadou. Let's see. Where I have too many tabs. Here we go. So this is Mark, who goes by Code. Mark Olson, you've seen him in the comments. Hi, Craig. Hi, Sheep Knight. Yeah, it sounds like talking about Bluetooth on the ESP32-S series. Sounds like the S3 will likely have Bluetooth as well. So Mark was kind enough to work ahead of me and like try to take my code and get it building more. I had this tab open, and Mark waves in the YouTube chat. Thanks for staying up, Mark. So basically yesterday, after I got the lower power stuff finally finished up, I started going through here and understanding all the changes that Mark had made, and saw how much further it got us along. So if we just look here, was it in here or in here? Nope. I'm always doing like multiple things, and I have like multiple tabs, obviously. Let's just see. I'll clean it and see how far we get. I realized that I had to do J1 because the output gets interlaced if you're running more than one job, which is annoying. And one thing that Ninja doesn't do, which is cool. So this is the CMake running. Team too many tabs. Yeah, Nina's in that camp too. Like, this is just one of my 2 browser windows too. Like, the other one has all my email and stuff in it. And sorry for the noise outside, but the window right here is open so that I don't get super hot. I am starting to get a bit hot already though, so I may actually have to open the window behind me to get a breeze going. The window behind me though, if I raise the shade, it reflects off my monitor, which is gonna lead me to even more squinting than normal. Okay, so we're now building the project from a clean state to see how far we get. And it's kind of hard to see, but at this point, I guess there's two things happening. I was trying to hunt down a lot of linking errors, and that is like, oh, missing this symbol or that symbol. And then there's also this problem of call target out of range, which I think is a matter of like um, what library we're including and how it's placing itself in memory. Which is, I was spending some time on it yesterday, and it's really annoying. It's really annoying. And I don't actually want to. I wanted to show it on this stream because like Ivan's in the chat, who confirms that there will definitely be an S series with Bluetooth. So that's exciting news. And yeah, so I wanted to cover this stuff, but I don't want to spend like 2 hours trying to fiddle with the linking stuff. I think, yeah, it says call target out of range. I think that's M long calls, but I don't, I think I do have it. I wanted to get it in front of you. I actually, one thing I did is I dumped all the symbols and all the libraries because we're like tacking our make on top of the IDFC make, which I also kind of feel is not a great solution, especially because what I've been fiddling with is in the make file. One thing we had to change was we were missing some linker scripts. And as Mark's pointing out in the chat, like that was one of the reasons that was causing the crash. But I think we do have M long calls in here. I mean, maybe I accidentally. Yeah, it's in the C flags, which will end up in the linker flags as well. I think it has to do with which library. Like I'm trying to pull in the libc, and I think I'm pulling in the wrong version for some reason. So basically, like these are weeds that I'd rather just put headphones on and like try to focus on for a while. I don't really feel like going over all of this today. The point that I really want to get to is this thing where we're undefined reference to app main. That's when we're actually going to start hooking CircuitPython into the IDF and FreeRTOS, which it uses. If you just build the project using the IDF CMake, these are the only two errors that you get. And so that is when we can start to look at FreeRTOS and how to integrate that into CircuitPython. But I don't really, I'm kind of stuck in this state of like, I don't necessarily know what approach I want to take with it. So I don't think I'm actually I don't want to spend too much time on this today. Then the other thing that I was doing for this linking stuff is taking like undefined reference to like ESP PM impl wait I and like trying to figure out what library that was in so I could make sure and link it as well. Yeah, so I got to figure that out, and I don't really care to do that today, but let's just run down the changes that Mark made. I think most of these I've integrated so far, and the ones that I haven't are because I don't really understand why they're there. And so maybe Ivan and Mark can chime in, and then when I pick this up next week, hopefully like Monday afternoon or Tuesday, because the lower power stuff's checked in, then I'll do another recap on Friday next week, and hope maybe, just maybe, we'll actually have it working, like the core working or something. But what I want to do is after this section where we talk about the stuff that Mark did, then I want to go in and start laying some foundational stuff and start preloading my brain on how the IDF's interfaces work. So looking at the pin objects. So basically, like the first thing we'll want to be able to do is like digital in and out, and being able to set things pin high and low. Mark says there's likely stuff that I shouldn't have checked in. It was a bit of a mess. Sorry. Yeah, no worries. I was using it more of as a reference for like, here's where I am. What in this diff do I think impacted that? Yeah, and Mark agrees. Blinky is number one. Yeah, totally. So I want to talk about how we do pins and peripherals and stuff like that a little bit later. So we'll get there. But let's just talk about here. One thing Mark was trying to do is be able to make without having the IDF path set at all. So that's what this is doing, is setting the IDF path and then also being specific about which components we actually care about. These are a separate set of C flags. I didn't copy any of these over, so they could be causing me problems. So yeah, I would have to play around with these still. One thing I definitely did do is added there. It turns out there's also generated LD files that the version that I was using last week wasn't using. I just had the ROM versions, and so okay. Mark says I just copied all the flags. Okay, yeah. So I didn't do that because I was curious to figure out what they all meant, and maybe Ivan can. I have a feeling. So these make sense to me because they're auto-generating linker scripts, and that's fine. And I think what we'll do is we may just tack on another linker script after these ones for being able to place based on the section names that we have in CircuitPython. The things I don't really understand are these like -u, which I have a feeling are undefined. Mark says the key thing was not using the C flags inside the LD flags. Okay, I'm still doing that. And that's an artifact of that most of our boards, we try to run link time optimization where you do want to provide C flags at the link stage, which we're not going to try to do. For those of you who don't know, link time optimization allows the compiler to like put functions from one kind of C file in another one and do cross function call optimizations, which can make your code quite a bit smaller, and smaller means faster generally. So I think these are unset if I had to guess. So basically, but I don't know that. I don't actually know what -u is. I've been meaning to look it up. Oh, he says, yeah, remove C flags just because it makes it harder to debug. I agree with that. Yeah, so not sure what these are, and I didn't copy them over, so that could be part of my problem as well. I liked this change of using the CMake dash, or no, that's the Ninja, the Ninja dash C to change the directory instead of doing it beforehand. I just copied that over. I thought that was a good idea. I did this as well to remove the libs because they were included in here already, I think. And then I did these because these are obvious. These are just changing the board name. Yep, deleting these pins is a good idea. And this is actually where I want to go today and talk a little bit about how this stuff works. This makes sense. I didn't change. So this SDK config file is the output of the kconfig processing. So if you run like menu config and you go through the menu and make decisions, that's what ends up here. One thing I definitely didn't do is I didn't change it back to a single app because although I don't plan on supporting OTA immediately, I kind of want to just, like, I know that people are going to want that in the future. So I'm just going to I'm going to have it as OTA anyway, even though we're not going to like officially use it out of the box or like at the start. I meant to look at this stuff, instruction cache stuff, but I didn't yet. Console UART, I wasn't going to change. Then this is just some deletions. One thing that Ivan and I talked about that I want to do, but I haven't done yet, is changing the way menu configs so that it doesn't write back out to the board. It writes to a separate place, and maybe we have a script after that puts the diff basically in the board's versions, because I want to have like one big default with everything, and then for every board I want to have a small file that just has the things that should overwrite the big default file. Okay, and I think that's about it. Mark turned off HID and MIDI, but I think they should work just fine. So I left them. We may have issues where depending on the chip, they have different numbers of endpoints, and the USB endpoints have different capabilities. So that could impact like whether you can have MIDI and mass storage and HID and CDC on at all the same time. So that is something that maybe we'll have to deal with later on in the port. For now, we can just turn them off. Okay, so that's kind of an overview. Are there any questions about that? I feel like I'm going faster than I normally do, but then again, I had like 30 minutes of DigiKey unboxing last week. Sounds like David Watts had a good live stream. All right. Well, drop the questions if you have them. Okay, so what I want to do today is one of the things that is kind of tedious, but every port needs, and that's pin definitions. And when talking about pin definitions, I wanted to talk about kind of the view of the world from CircuitPython, because maybe I've talked about this on the stream before, but lots of HALs and so hardware abstraction layers that vendors provide don't kind of jive with the mental model or the way that CircuitPython's APIs work, which is basically we're running user code. We don't know how people are going to configure or what they're going to want to do with CircuitPython. Whereas a lot of hardware abstraction layers are designed for like configuration at compile time rather than at runtime. Wow. Johnny's almost hit 50K subs. Yeah. So if you haven't, you should subscribe to Johnny Bergdahl on YouTube. I haven't yet. What do you stream, Johnny? Oh, I'm in the Adafruit account. Hey, look, I'm live. I'll give you a sub right now. I'm spelling it wrong. 49.9 subscribed. Cool. Is it possible to push your changes so I can start to test things? Yes, Mark. That's a great idea. I can push what I did. Oh boy. I changed more than I remembered. Quarantine while sheltering. Johnny says thanks. When in doubt, run git status. I make no guarantees about the state of any of this. It's good to add specific files because you may snag stuff that you don't want to add. Like I don't want to add the 3 untracked files. All right, we got 2 subscriptions for Johnny. I don't think the microlab thing is anything. I did have to change some building stuff. Stephen Colbert on the YouTube suggestion. Oh man, Johnny's at 49,999. Somebody's gonna be the 50K. I was too early. Oop. Sheep Knight subscribe to. Let's see what I changed here. I was trying to figure out why something wasn't. Oh, it must be a trailing white space. My editor deletes trailing white space, so. Okay. I think we're good. More build progress. Yeah, some of the stuff I did was like, nice. Johnny's over 50K. 50K plus 2. Yeah, I guess I could share that. You can see my, hey, it's 50K now. SMD soldering. There you go. I should be able to post URLs. All right, and I committed, and I'll push so that Mark can pick up where I left off again. I should be able to circle back on Monday, though, which will be cool. Once I'm through email and reviews and meetings and stuff. Okay. That's that. So the other thing I wanted to, or the thing that I did want to accomplish on the stream today is prepping for Blinky. And by prepping for Blinky, I mean I want to lay out the pin definitions for the micro, and then I will also do the pin mapping for the Sala. As I talked about with CircuitPython, we don't know what the user code's going to do. So we basically say, when you construct an I2C, you give it the pins that you want I2C to be on. And if there's a hardware peripheral for it, it will work. If not, we'll raise an exception saying those pins aren't valid. David wants to know who the 50,000th subscriber was. But yeah, I doubt there's a way to check it. Okay. So let me pull up, actually, I'll do it in my editor. Get this all sorted out. Let me show you the structure of an existing port, and then we can do it for the ESP. Because I actually want to look, I forget how it's done on the other stuff. Close other tabs. Don't save. I don't think I need it. Some of these files are things that are from different stuff I was working on. So the low level, so what we do is we maintain two versions of pins. One version is from the microcontroller's view of the world, which we can pull up in the data sheet. So let's just scan through here. Block diagrams are great. Peripheral pin connections. So this is something that's really interesting. This is a mapping between internal signals and external pins, which we'll talk about in just a second, but I was hoping for this. So this is one view of the world. Is what are the names of pins with respect to, let's see. What are the names of pins with respect to the chip itself? And then we have a second view of the world, which is what are the names of these pins, but as they're called on the board itself. So we have two stages, and this is one of the reasons that it's super easy to add a new board to CircuitPython, is that the port itself operates on pins at this level of the chips level, and then all a board has to do is say like, oh, we call SPI Q by this other name, or we use it internally for this other thing, and that's up to the board. Um, so for any pins here that we have control over, we're going to want to make a definition. For, and then the the modules are interesting because they also have pin layouts, and you can see here that they actually have renamed the pins here as well. So CircuitPython doesn't have a great way to have like an intermediate name. Instead, we tend to just go on the chip itself. And we should be able to figure out, kind of reverse engineer what pin name based on the module is on the chip itself. But we do it at the chip level first. Craig says, ultimately it goes down to machine code level and registers. Not sure what you mean by that. But yes, like our pin objects operate on the microcontroller level so that we can know what registers associate with them. So let's compare and contrast. So I want to look at the SAMD stuff. So let me just pull up the SAMD datasheet. And yeah, okay, so Ivan says the module pin names should mostly be the same as chip pin names, subject to change, like GPION is ION. Yeah, I figured that. That would make sense. Yep. Yeah, we'll just verify that, but I don't think that we could add comments that say like, oh, by the way, this is chip X or name X on module Y or whatever, but from the actual like structs that get baked into CircuitPython way, we won't have that intermediate step. Maybe we should. So here's an example, and this is the reason that we do it this way is that ESP32 just has one chip size, but other microcontroller families have multiple sizes and layouts. So like the SAMD21, for example, this is for the 64-pin versions, and this is how they're laid out around the outside. And then they have these names of like PB15. P is usually stands for port, meaning that like it's one peripheral that's managing that set of pins. But then you can see like for the BGA, it's reorganized, and then there's a smaller version. So this is only 48 pins, but like PB17, which is what I was showing, is like not available at all, but it still has the same properties. Here's a QFN 48, QFN 32, so even getting smaller and smaller. Chip scale 35 pin. So the availability of pins varies with which package you're using, but the properties of the pins themselves don't actually change usually. So this is then that part of it. This is the pinmux matrix. So the names that we use in our microcontroller module are these pins here. These are the names that are universal across the package. David says, I should know this, but what does PB actually stand for? I think PB is port B. So it's just a group, like the port is the generic thing. And then, yeah. And then the B is just like which copy of the port you're talking about. But yeah, PB, as Bruce points out, does also stand for peanut butter. I don't know what PA stands for then, though. Peanut almonds? Peanut. What is yeah, port B. Yeah, and you can get port C and port D as well. Is there a good picture of that? So since we're looking at the SAMD datasheet, there's this port peripheral, which is an IO pin controller. And it says each port group can have up to 32 pins. Yeah. David's okay with PB being peanut butter. Okay. So let's see how we do it in SAMD. So because these are microcontroller level names, they go in. I think we talked about last week or the week before, but CircuitPython has this structure where we have shared bindings, which is like a shared Python to C conversion layer, and then each port implements a custom C stuff on the inside, which is called Common HAL. So this low-level microcontroller stuff lives in Common HAL microcontroller pin. And then there's some basic helper functions like keeping track of which pins are in use, and then some special cases for pins that are special, like SWD. And keeping track of which ones are in use, which ones are free. And then somewhere here, maybe it's not even in here. Okay, so this is the start of it. This is mapping pin names to pin objects on our. You can do import microcontroller pin. Maybe I should show this. Should I show this? Would it be confusing if I used an NRF? I've got a Circuit Playground Bluefruit on a USB cable here. Let me just plug that in and we can pull up the REPL and I can talk about this a little bit. Because I think this is one of the powerful, I know this is one of the powerful things about CircuitPython. I was having a conversation with Paul from Teensy, and he was talking about the challenge of getting like a second I2C going with Arduino. And it hadn't even like crossed my mind, because in CircuitPython, you can construct I2Cs as long as pins are free and are connected to a peripheral that's free. Like our code underlying it doesn't have that baked in. It's not baked into anything. So let's just Control C this and we'll get in the REPL. So there's two primary ways to refer to pin objects. One is through the board mapping. So if you didn't know, you can do tab and it will autocomplete. And the other way you can do it is you can also, in Python, you can use dir to find all the attributes of an object. So that's two ways to get names of things on an object. So these are the board's names for pins on the microcontroller. So if we just do board.d2 and we see that we actually get, it prints it out as microcontroller pin.a5. So I can do import microcontroller.pin.a5 or that, and then I can do microcontroller.pin A5, and it gives me it didn't work. There's an import bug. I thought that worked. Oops. It's not perfect, but you can do pin A. What? I found a bug. What's this? What does this object have on it? Oh, interesting. That's not right. Craig says microcontrollers operate at a base level of assembly language. Correct. All computers have a language that a compiler compiles down to that it executes. There's lots of complexities there, but the general idea is that there are instructions that the CPU will read and follow and perform an action and then go to the next instruction and perform another action. That's what assembly language is. Geek Guy says, can I make the browser text larger? Yes. Do you mean this text? Wait, I'm in some PDFs. That should be slightly better. What Rod Wilson said, pin with a capital P. Yeah, so pin with a capital P is actually the object type. So it's actually a class. So I don't know why we're getting pin A5. I think that's a bug. What it should be telling us is that. um, but if we do microcontroller.pin with a capital P, um, it's the class, and you can't construct it because we have static versions of pin already. So if we do the type of this object, it is already a pin. All right, let's scroll up. Happy birthday to Unexpected Makers Kids. Andre asks, off question, for sending MIDI commands via USB with the ESP32, I need an external CP2102 or other serial to USB. Which one might be? So if you're sending MIDI commands via USB with the ESP32, you can't do that I know of, because the external CP2102 explicitly, it might have the ability to do MIDI, but as far as I know, it's just presenting a serial connection over USB, and that's kind of all it does, is it interprets between a CDC connection, which is like serial over USB, and UART. Native USB, though, like on the ESP32-S2, can actually do proper USB MIDI, which TinyUSB supports and CircuitPython supports. So once we actually get everything building in together, it should actually work on the ESP32-S2. And that's the same reason that you can't get like mass storage to work where it shows up as a drive. It's because the CP2102s only deal in serial. So I can answer that question. Yeah, Craig says, so the port B and stuff is directly attributable to the register assignment of that. Yeah, that's the general idea. Basically, what port it is means which 32-bit register the pin functionality is accessible in. Unexpected Maker gets right to the point and says, you have CircuitPy up on the S2? And the answer is no. We're still having linking trouble. Mark made some progress. I made some progress. I just shared it with Mark. And so expect to see more progress, because the lower power stuff I was working on is now checked in. So I should be able to actually spend like all the coding time I have next week on CircuitPython on the S2. So hopefully soon, hopefully in the next week or two, we should be able to get it. Yep, and Mark recaps that we're talking pins. What do you mean this is not in the S2 boohoo? I don't know what you're talking about. Yeah, it's great to get lower power checked in. Now other people can help me make it better. And it's interesting because when I over this week I updated my S2 work to be based on that as well. So I had to change a few APIs. And when I do the timekeeping, which is one of the early things you have to do, like maybe we should talk about how you get to Blinky. So once you're linking, what are the things you actually need for Blinky? Well, you need to be able to refer to pins, which is what we're talking about right now. You need to be able to set a pin high and low using correct. My terminal is on a Bluefruit right now. Oh, that's why you thought I got it going. No, it's on a Circuit Playground Bluefruit. And then time. So to blink, you actually need to be able to sleep. And so that'll be a thing to get going. That should be hopefully pretty easy if we use the FreeRTOS timing stuff. So we will see. But what I was talking about in the terminal here is that we have two names for pins. Sorry. Yeah. so we have the internal names, the microcontroller names, and then we have the board names. So we found one place. I'm going to just minimize this. We're not going to use that. We found one place that was related to this structure here, this pin global dictionary, is the way that the names get into that object, the microcontroller.pin module. So I'm just going to copy that over and just start laying the groundwork on the ESP for it. So here we are in ESP. We're in init again, just like atmel samd. And I'm just gonna paste it. Now, samd is pretty cool. It has macros for each pin. So I showed the data sheet and how like the different sizes may or may not have pins. So we're able to just use the HAL's version of like, oh, I know that for this specific SAMD, it doesn't have that sort of thing. So that makes it easy. And then these pin objects do take space. So we also have this ignore pin thing as well, which I'm going to simplify it. And right now, let's just do the grunt work of getting the names from the ESP datasheet. Are there questions? Oh, I thought I saw one. Oh, I think I'm all caught up. Okay. I have two copies of the chat. I have the one that I can see in the like OBS window that you can see, and then I have the one that I can actually reply to. Okay. This grunt work actually should not be bad because there's only 56 pins, whereas like on the what is this? A super sticker. All right. I don't drink coffee. Okay, so this isn't too bad because there's not that many pins, but for the IMX RT, where they have like 230 pin packages, like it gets very tedious very quickly. And this bit here is not even the worst part. So I'm actually going to take this and I'm going to actually drag it where you can't see it just so that I can have them side by side. And I'll try not to overlap the chat as well. Yeah. So yeah, no REPL on the S2 yet, but I'm slightly optimistic that I'll be able to get it by next week, if not the week after. Okay, so VDDA we don't need, LNA in we don't need, VDD3 2 pins we don't need. So it looks like it's just gonna be GPIO. And my policy is to copy the datasheet. I don't want to. The only reason I would have to not follow the datasheet is that Python identifiers can't start with a number. So if there's no prefix there, then we'd actually have to be creative. Anybody know how many GPIOs there are? I know this is riveting live stream stuff. It's all gotta be done. Okay, I see through 14. And Ivan did say that you can refer to the other things as as numbers as well, but I actually don't. I want to follow the data sheet because most users don't see it at this level. The users will see it at the board level. So it's easier. Like I imagine when people are creating, their schematic symbol, they're gonna follow this thing on the data sheet. And so that's what I want to follow internally as well. So I guess I should say that for a given board, if we look at like, I don't know, any one of these SAMD boards, we have so many now, it's incredible. But like Trinket M0, and we look at this is the pin mapping for the board objects. So it's just taking, so this MPQ string is complicated, but it's basically a way for at build time, we deduplicate strings and we give them a number and then just store the string once. And so this is the mapping that people will see and use. And you can actually give multiple names to the same pin. So that's why they're separated out like this, is that the top one is the one that when you print it out, you'll see. And then the bottom ones are alternate names that you can use to refer to it. And then they all refer to actually the same object, which is also available through microcontroller.pin. So I'd rather copy the names on the data sheet that people are going to use in their schematics for when they're designing a board. So I think I'm going around, and I think I'll just keep going around. It's possible that these crystal, I guess let me scooch this back here. So I just did 0 through 14. And now there's this power pin. This is power for the real-time clock. Then 2 crystal pins, and then DAC pins and GPIO again, and another power pin. And then more GPIO and blah, blah, blah. So I'm going to skip any of the ones that have VDD because those are clearly power pins. And then the other ones I'll do by their name. Yeah. And we might get it wrong and we might have to add more later, but this is me just laying the foundation for when I get it compiling or linking. I guess it compiles, it just doesn't link. Okay. Oh, I already copied it, didn't I? So I don't know if the crystal ones are general purpose, but I'm gonna just do DAC1. DAC2. And again, these names aren't consistent, right? Because there's an underscore, but I'm just going to copy the data sheet that they, however they refer to it. Okay, perfect. So Unexpected Maker asks, so how will you handle the GPIO matrix where any pin can be routed to almost any peripheral? I missed if users can use the pin number instead of the pin names. And then both Unexpected Maker, Mark, and Ivan point out that the crystal 32 pins can also be regular GPIO. So I will go back and add those as well. And I should answer Unexpected Maker's question. Yeah, you're getting ahead of me. So pin matrix. Let's talk about that a little bit later. There's a couple approaches. So first thing, these names are only the names that we basically use in that board to microcontroller naming stuff. So I don't really care what we call it. It's just a name, and I'd rather use the name that is referred to everywhere. And then there's a couple approaches to pin matrixing that let's talk about just a little bit later, unless you have to go, and then tell me you have to go, and we'll do it now. But that's something we can talk about once I'm done copying this table. Because right now, this is just a mapping between a name and an object, and we actually have to define these objects. And when we look at those objects, you'll see where we have to talk about the matrix stuff. Because there are now two approaches that we've taken with it. Okay, so we got time. Let's just do this a little bit more, and note that we're like totally making more compilation errors for ourselves because we're referring to a bunch of objects that don't exist yet. But that's okay. We're going to add them next. Okay, so the power pin we don't have, and then we're going to have pin 21. And you think this is tedious, just look at the IMX ones. Right, but so Mark says you can basically go up to GPIO 46. I can, but I don't want to call it that because I'm assuming that people are going to, when they're creating schematic symbols, and maybe I should look at Unexpected Maker. I'd actually be curious to see what you did on your designs. But what names do you use in your schematic for pins on the microcontroller itself? Because my goal is that I want to make it as easy as possible for a board designer to map between board name and the name that they use on the chip. Mark says, I did the 144 pin BGA pin map for STM32. Yeah, it gets way, way worse than this. Okay, so next up, we start doing some SPI stuff. SPI CS1. And again, these are just names. I know that the pins can do more than that. We'll talk about that in a little bit. Johnny says, I use the pin names. Okay. Oh, yes, I did. Thank you. Thank you, Simon. I will do it in just a sec. HD. What does HD stand for? Hold, I guess. That makes sense. I was like seeing write protect, and I was like, oh, hold is the other one. Yeah, so anybody who's done an ESP32 board yet, I'd be curious. Oh, so on your schematic, you just use pin numbers. You never name them at all. Because most of Lemore's schematics, she'll actually have like really long names that have all of the things, like most of the things that they can do to remind her for all the pin next stuff. Which is actually, I think, one of the things that could be cool to see integrated in like KiCad, where you could say like, oh, I want an I2C, and it would tell you all of the different I2C capable pins. Like it would do kind of like the pin mux stuff for you. Bye, Nina. Thanks for watching. Okay, Unexpected Maker says, then on my board cards, I list default uses for each pins and stuff like ADC groups. Never on the actual board itself. Right. Rogan says, wouldn't it not be easier to copy and paste the pin names directly from the PDF and then use a couple of lines of my preferred scripting language, which is Python, to generate it? Yeah, that can be the case, but I don't know. That's certainly the case for like the hundreds of pins things, but I also kind of just like, for me, sometimes it's also about just learning the chip, I guess. So like I was like, oh, what is hold? Anyway, I'm almost on the final stretch here. We got lots of good conversation going on. Yeah, especially if you have 200 pins. Yeah, for sure. Although it's interesting because haven't necessarily found a good resource for the pin mux information, which if you think this is tedious, the pin mux information is way, 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 way worse. Mark and I were talking about that some, and we can have that discussion in just a bit as well. Spook is down in his bed. My kitty who has seizures, but he actually had one earlier, and so I'm hoping that he rarely has them two in the same day, so he should be fine. 38, 4, 5, 6, 7, 8. I know this is boring, but our theme has kind of been like the tedious parts of programming and spilling water on your keyboard, which a lot of people enjoyed too. Yeah, Rogan agrees with me. Machine readable data sheets. Yeah, so there's a couple interesting projects in that. Maybe we should just talk about it. One is, let me move my browser back. So I'm on the embedded FM Slack, and I was asking about this, and there's this project called Modem.io, and they have a modem.devices repository, and I poked them, and they actually just added the SAMD stuff as well, but they've got, I think it's XML, like a standard XML format for kind of machine readable sorts of things. Oh, I can make this bigger too. So now Geek Guy wanted to see it a bit bigger. I'm really pretty allergic to XML. I definitely I feel like TOML's kind of come to be the thing that I would use for like not a scripting language sorts of stuff. And then what was the Google project? There's a Google one. Cyan, byte. That's what it is. I was looking at this. This is the same idea of like machine readable data sheets. But there was one thing that kind of scared me away. It's YAML, which is fine, except the reason they came up with TOML is because there was parts of YAML that were not well specified. And then if we... Where did I find it? Hey, I recognize that person. Is it in peripherals? No. Yes, right. So this is only for like I2C devices right now. But the thing that scared me away was the fact that they have logic in them. So this makes sense to me. This is just for like a particular register. But if you scroll down, there's actually a function section, and then they have like logic in YAML, and I was just like, I'd much rather use Python. I'd much rather use Python. Like I'd rather come up with a way to take a Python AST and then generate C out of it or whatever, which the Python library I think actually does already. It's just like you're basically inventing another programming language within a language that's not designed to be a programming language, which is weird. So yeah, it's an interesting idea. Yeah, Johnny said, ouch, that was ugly. Yeah, I think I think the idea of machine readable drivers and documentation is an interesting one. Obviously I have a Python bias, but like it feels to me like there could be a tool to cross compile from like well-written Python code to some other version. Okay, we made it all the way 3/4 of the way around. And then we have these M pins. Sorry, maybe I shouldn't have started this, but since I started it, I want to finish it. Mark, I think your MCU DB is private, so I didn't want to mention it. But yeah, if you're interested in working on it, chat with Mark, who is code on K0D on GitHub. But I don't think that information like the pinmux stuff is not something that manufacturers typically provide in a machine readable format. So maybe we can convince Ivan to give us like an Excel version of it instead. Okay, do the other crystal pins, are they generic as well? 0TXD. I think we just have 2 more. Oh no, I forgot to copy it. Wow. Did I just update the same thing twice? All right, let's move on. All right, unexpected maker says they're just crystal pins. Yeah, do I have a link to MCUDB? I think it's an org. You find it and I'll drag my window back over. So Mark and I have been talking about this idea of a machine readable datasheet stuff. So if you're interested, Mark made an organization for it and has started adding it and is using TOML for that. Here's the link. All right. Andre also says, thanks for reply, Scott. As Ian says, a USB host module will be more appropriate for MIDI USB. Is it possible to make ESP32 a hybrid MIDI device, BLE and USB? If you're interested in that, I'd recommend looking at the NRF52840. It's got both built-in USB and BLE, and it can do both BLE MIDI and USB MIDI. The ESP32-S2 will be able to do USB MIDI, but it doesn't have BLE, so we'll have to wait for the S3 to do that. Okay, so we're past this boring part. Now let's talk pin matrix, because this was something interesting. So there's kind of 2 approaches to it. Let's look at the Atmel SAMD version. And I think we have it in our peripherals. SAMD 21 pins, yeah. So we have this very boring extern stuff for all the pin objects that we have. And again, they're guarded by if defines, which are taken from the HAL. And then we have, maybe it's here. Yeah. So we have this top level struct for this top level struct that basically encodes all of the pinmux information. And it varies a little bit. So like pin number, whether it has an external interrupt channel and what the channel is, touch Y lines. So this struct can be specific to the particular MCU. The way that like shared bindings and common HAL works is that the common HAL stuff is can have a struct all of its own shape, except for the first member of the struct always has to be a type pointer. And it's not actually, you don't see this type pointer directly, but that's what this pin prefix fields is used for. We tried to create the peripherals directory not closely tied to CircuitPython, so we use this pin prefix fields to be able to plop the type pointer in there, or the type information. It may not just be a pointer, but yeah, it's a struct. And basically, like, that's what characterizes a Python object, is that the first field is always a point, or like a reference to the type of the object. So this is one approach that we took, where for every pin we keep track of like which ADC inputs it has, what timers it has, and what circoms it has. And it is basically, so this is the SAMD datasheet. If we look at the IO mux stuff, it's basically like one for one, like this is one object, and the like what the struct represents is all of this stuff. So like, oh, it's two circoms. Well, it's too long because of these two things, and then it's two timers because of these two things. That's one way to do it. And then the other way that we've started seeing in CircuitPython is this has the disadvantage of if you like have 100 pins, but only 10 of them can do I squared C, for example. Like, it may not make sense to store I squared C related muxing information for every pin. So the way that it's done in, I think, both STM and IMX, but I could be wrong, is that it basically has a separate table to store that information that stores references to the pins, that like all the pins that could be SDA and all the pins that could be SCL, for example. So ports have flexibility. The high level is that ports have flexibility on how they want to do this. The contract that CircuitPython imposes on the port is that it has to be able to figure out, given two pins, whether I squared C can work, and if it can work to do it. So if we just look at STM and the way that Lucien did it, pins.h, we can see that the only information we have per pin is the ADC unit in the channel. For other stuff, he has this. Oh, it's not here. Let's take a look. Let's dig. So here's all the pin objects, and this is what we'll do there. Geek Guy says the only NRF52840 board I could get from DigiKey is the Clue. Yeah, I was looking at that too. Looks like all of the less expensive ones are out. Clue's a great board though, because it's got a screen and it's microbit shaped. So we're gonna want to do this. Perif.c, thank you. So yeah, thanks, Mark. So the way that the STM port does is for all I squared C things, just make a list of which pins are valid for like SDA and SCL. So it's up to the port on how they want to do that. So let's now figure out which approach that we want to take with the S2. So let's pull up the data sheet, and I'll finally scroll down like y'all wanted me to. I think it's here. So here we have a list of, you can't see it all, but it's a big table of like, oh, GPIO 0, what type of pin it is, which I guess is really what I was asking of, like, can it be a generic thing as well? And then what functions can it do? And this is also interesting, and something immediately that looks interesting to me that is not something that we've dealt with so far. But it's that there are two options for a GPIO controller. This RTC GPIO 0, and there's GPIO regular GPIO 0. Now my assumption, and Ivan can correct me, is that good night, sheep. Sorry, I probably missed it and you're already gone. Glad you like it. But usually we only have one option for like when you're creating a digital in-out, which one to use. So we'll have to make. I know that there is actually a second CPU in the S2 as well. It's just the low power CPU, which is a RISC-V CPU, and I think that's my guess at what the RTC GPIO 0 is versus the regular one. And so when somebody instantiates a digital in-out, we're gonna have to decide which one they actually mean. I have a feeling what we'll probably do is when I implement it, I'll probably start with the regular GPIO. Because it's probably faster. Yep, exactly. So Ivan says the RTC GPIOs are useful for two things: sleep mode wake up triggers, and for the ULP coprocessor, which is the RISC-V. It can be RISC-V or not RISC-V, but like if I were to use it, I'd only use it as RISC-V. Then it has access to it. So in that sense, if we're comparing to the SAMD21, I would treat the RTC GPIO as basically like the SAMD's external interrupt controller, which can't output anything. It's only interrupt or input stuff. But that's what a SAMD would use for wake up triggers. So when I'm doing digital I/O, like I'll default to the GPIO there. Native touch is really interesting as well. So let's look at this. So we have two options, right? We have to figure out what data we want to store for every pin object, and then what peripheral data structures we may need to figure out like which pins work for I2C, like built-in I2C. So it's like we might just want to have pin number, which would basically be this. And then yeah, there's not a whole lot. Like there's a few SPI options, a few UART options. It is quite nice that like all of these are linear. So like ADC2's channels 0 through 9 are like on incrementing GPIO pins. Like that's really nice because we don't really need a table to encode that. We can just have code. Okay, so Ivan says that note that some peripherals like you are listed in this table, but they can still actually be mapped to any GPIO through the GPIO matrix. So that makes it easier and it makes it more like NRF. Let's just take a look at that as well. Because basically when you instantiate a UART object, we've got to figure out like, is it possible? And if it's possible, with what peripheral to do it. And so let's just look at, this is the data sheet. We're probably going to want to look at the reference manual. Not this. Although there's this GPIO matrix. Is this what you're thinking? Okay, so how does this work? Input signal, output signal. 210. Peripheral pin configurations. Okay. Right, so the table I was looking at was truncated. Ah. Interesting. So, yeah, these are interesting. Any GPIO pins is interesting. That basically means that like there's no reason for us to store UART or I2C data in the pin objects themselves because they can be mapped anywhere, right? Like our code will be pretty simple. And I2S is that way. Infrared controller is that way. Spy 0 and 1 and spy 2. So spy 0 and 1 are specific. So the way that I would expect CircuitPython to work is that, like, if you happen to give us this set of pins, then we should pick spy 0 or 1. Otherwise, if you don't, then we'll use spy 2, and then if you try to use spy 2 again, then we won't work. Generally, like, the way that CircuitPython deals with conflicts is it assumes it just fails as late as possible. So, like, the first thing wins. Okay, so Ivan says ignore spy 0 and 1. Those are used for the main spy flash by the IDF driver. Right, cool. Yeah, and I think, like, when we're going, we want to assume that I think we're going to assume we're going to always be in a position to have flash and PSRAM. Yeah. Unexpected Maker says, yeah, don't let folks use those pins. Cool. And that might be a reason, like, it may not... So that's these first 1, 2, 3, 4, 5, 6, 7. I wonder if we should not even list them in microcontroller then, if we're going to assume that they're always used. That's something we could play with. Crashy. I mean, generally, like, our model for whether a pin is in use depends on the state of the, like, registers. So we, like, even if we expose those pins and people try to construct it, we'll say it's already in use. Okay, there's a spy 3 as well. And a pulse counter and USB. Yeah, so, like, USB we don't even usually expose because we always use it. All right, well, I think what we should do is we should just... I could just make pin objects for that. Let's see, it's 3:30. If you have more questions, ask them, because I think this is going to be kind of boring. But it's something that I think I'll do is just sketch out all those structs. We could also do the cell mapping. Maybe we should do that. Maybe that's actually more helpful. It certainly would be make Blinky easier when we get there. Let's do that. Let's start from the other side. Boards, pins. And I think I'll copy the microcontroller version. Ivan suggests putting ADC, DAC, and touch pins in the pin structs. That should be good enough in the first approximation. Yeah, and I think that's exactly what the STM version does as well. Okay, let's just snag a couple of these. And take a look at the cell. Oh, you know, the other thing I wanted to look at was the IDF and see if the IDF... Good night, Rogan. Thanks for watching. I don't actually, like, I've not used the IDF before, really. So let's just see if we can't take a look at the API reference and just figure out, like, we can probably build on top of it. Let's just look at I2C. Parameters of the structure I2C config. Okay, so it's not done in menu config, which is good. we pick the mode, we pick the pins, we set the clock speed, port number in the structure. So it's dynamic, which is good. One of the 2 port numbers from I2C port. Nice. Commands. Link create. Interesting. Well, that's good. We can take a look at that later. My fear is that some HALs don't allow you to initialize peripherals on the fly. And so we end up having to do it ourselves. But this looks like it, because it's done with a struct, it's all dynamic, which is cool. All right, that's good progress. Let's do this pin mapping, and then I think we should call it. So let's see if we can find, we have the data sheet, we have the module sheet, and I think the naming on the board itself, where is the board? I think the naming on the board matches the module names, if I'm not mistaken, but it's always good to double check. And I can point out, let me switch. So when you're coming up with the names for the board module, it should be as close as possible to what's on the device itself. So on the device itself, most of them are just numbers, and that's actually not valid Python. Sorry, it's like freaking out. So either I think I'll prefix with P, or I'll prefix with IO, because IO is what the module prefixes it with. And I think that might be clearer to just use those prefixes. It is interesting that TX and RX are labeled instead of the number. And in that case, what I'll do is I'll actually do 2 defines, one with TX and RX, and then one with just the number version. So yeah. Vote in the chat whether it should be P or IO. I think it should be IO, but make your case for P. And actually, let's see if we can't find the cell schematic, just to, make sure that we're not wrong. It's always good to make sure that like your expectations match what actually was the case. Hardware reference. Schematics, perfect. This is why open schematics are useful. Oh, you can't see my screen. That's the wrong one. That's the right one. Okay. So if we just look at the module here. Zoom, zoom, zoom. And we can see that they all just match up. So it should be straightforward. (19 and 20 are USB, so I won't include those because we assume that USB is always going. It's CircuitPython. Okay, so, and then this should be the case as well, but this will help us map the things that are not named in that one view that way. I don't know, maybe we should change that. Okay, so I'm just gonna let this. The top edge is 0 through 17. And no one made an argument for P, so either I put everyone to sleep or they really don't care. Ha, look at that. Oh no, I just realized I should only be doing one side. Yeah. Where are my letters? Ten through 17. So I want to do 10 separately. Craig says, thank you very much for the stream. I'm glad you like it. I always think that people are really bored out of their mind. Good night, Craig. Sleep well. Thanks for staying up. I know for Europeans it's quite late, so I appreciate you stepping in. And for those Australians, I appreciate you waking up and watching. Mark asked if I know about control shift up and down multi-cursor. That sounds crazy. I could try it. Multi-cursor. I'm on Mac. Is it still control then? The problem is that all my controls and commands are not the same. Oh. Yeah. I do get a little hindered by the fact that I have a weird keyboard. Oh, there we go. What? What is this? It's a giant. Do I just get a giant one? Cool. All right, I'll have to try that. Y'all are blowing my mind. I think, though, that it's important to say, for new programmers at least, that it really doesn't matter. Like, I think new programmers get really hung up on the idea that they're too slow typing. And so I'm kind of okay being slow because I think that the hard parts of programming are not how fast you can input to the computer, but rather the like debugging thought process and the design of systems, right? It's not how fast you can type. And I think that can stop people from getting into it. And I'd rather not stop people from getting into programming. So I appreciate the tip, but beware that it can stop some people from jumping in. Okay, so 18 and 19 are these ones. And I'm starting to think that I really shouldn't have used these names. Yeah, Johnny says typing faster is just creating bugs much faster. You need time to think. Mark agrees. There are just a few things that really help. This is one I use a lot. Totally. Geek Guy says, I really enjoy these streams and I'm learning a lot from them. Someday maybe I'll get brave enough to poke at the core CircuitPython code. Yeah, please do. It's not that scary and we're always happy to help because we want more people to be able to do core CircuitPython. And Unexpected Maker agrees as well. Typing speed does not equal coding speed. Okay, I think I've changed my mind about this. That we should have just named them GPIO such and such. So I think instead of changing this, I'll change the other file. So I'll finish this and then I'll go back, fix them. This is 19 through, okay, but it doesn't have everything broken out. So it's 18 through 21, 26. All right, let me do your fanciness. It's like 3 presses on the same side. Okay. Oh, how do you get back to 1? 18. I don't have arrow keys on this keyboard. Duke says that multi-cursor reaction made me laugh. Yeah, it's new to me. It's good to always be learning things. Talking about, you know, skills that are good to have as a programmer. Like always learning new things is part of the game. And I hope that like people tune in and aren't like, oh, look at this noob, because I'm not a noob, and you have to understand that. Like, I've been programming since 2002, and I worked at Google for 6 years, and now almost 4 years at Adafruit. Like, if you think I'm a noob, you're underestimating me. It's not just about typing speed. 2, so 36 through, or no, 33 through 42. I wouldn't need multi-cursor if I was smart enough to copy and paste the prefix. 33, 34, 35, 36, 37, 38, 39, 40. But then we're going to do TX, RX, and 2 more. And then there's reset and ground. Bruce says, at one time there was a term called yak shaving, a trap where one concentrates on the tooling as opposed to the coding. I'm susceptible to that. Yes, I am as well, which is why I really want to switch to Python plus Ninja for our build system. Geek Guy says, whichever is more descriptive is what you should go with. That's a good question. The problem with the DAC1 names is that they're only descriptive in one vein. They don't encompass all the different things that happen. Oh, okay. So Duke says 2 things. First, yeah, I'm always happy to learn new keyboard shortcuts. I always try to show all the people I work with all my favorite shortcuts, and also flip it around, copy 1 through 9, and then put your 1, 2, or 3 in front using multi-cursor, I assume. Which is interesting. But this is so much more fun. Oh, and it's not even right. 33, 34, 35. I would do that if I wasn't already... in the weeds. Those of you who have worked with me, you know I like to be in the weeds. Okay, 41, 2, 3, 4. There's many more efficient ways of doing this, but it's one of those things that's also like you only do it once. And of course I forgot 40. And I'm only going to 46. Like, typing speed doesn't help you if you're trying to figure out a bug. And Mark, +1's the Python plus Ninja build system. Yeah, that's really what I want to do. Geek Guy says I can hunt and peck faster than some people can type. Yep. And Duke Cox points out, we can't make you too efficient, then we wouldn't have anything to watch. This is pretty low efficiency for me because I'm chatting, but so I don't think you have to worry about it. But I think I think this will be interesting. Like this is a really interesting time in a port's life, um, and hopefully by doing these like Friday snapshots, we'll kind of see like over time how the ESP32-S2 CircuitPython port evolves, because it's definitely a priority for me. So it's not like I'm gonna get pulled on to something else anytime soon. And obviously, there's people invested in it, so that's cool too. Okay, so 37 and 38 are. Is that right? This would be 43 and 44 are. Yeah, yeah, okay. 43 and 44 are TX and RX. So I'm going to take this and then I'm going to copy it and do TX and RX. I wonder if I should make them the second one. I guess I'll make them the first one because that's how they are on the board. So that's our board definition for the Sala. There are some other things that we can do that are not in here, but are in other boards. We can give it a default UART, which I think we do want to do. And so if we just pull up, it obviously won't work right now because nothing works right now. But for boards that mark pins for specific things, then we will explicitly allow you to do like board.uart parens and then give you a singleton for the one that the board kind of defines as the de facto UART. Which I think if we look here, yeah. So this has like default UART bus RX and TX. So let's just copy that to the Sala's MP config board. And we decided RX is GPIO 38, no, 44. And 43. Yep. All right, so whenever we get that working, we'll be able to use that. And we got 9 minutes until 4 o'clock, which is 2 hours in. If you have any more questions, ask them. I'm going to redo this. And maybe we'll get my multi-cursor chops up to snuff here. I guess I'll just delete this much. And I'll do GPIO. One. Doing it backwards again. Oh, wait. I'm adding these. I'm going to take, it was Duke's idea, I think. If I do multi-cursor. It's so weird. I've got to do, hey, look at that. It's just a weird button combination. Because to get my arrow keys, I also have to hit function on the keyboard. And then these were the pins that you were saying we shouldn't allow people access to, along with the CS one as well. So I think I'll just comment these out. These are always used for onboard SPI flash and RAM. So we'll leave those there. What about 26? We broke 26 out, which is SPI CS1, but I didn't think we wanted to break it out. But I guess all of these are still broken out on the. Okay, Ivan says knock them out at the board level. Because it is possible to build a board where the SPI flash is connected to a different set of pins. Flash pins can be customized in eFuses. Okay, so you'd recommend then just calling these by their GPIO names? That's my guess. So if we look back at this thing you can't see, sorry, this is what I'm looking at. So we went up through 21. So we have 21. Okay, so there's a gap between 21 and 26, and then to 33. So we go back in Sublime. We're not going to name them this anyway. So we just need 26 here. $19, $21. Wait, this is the module. This is the module. Right, so I need to look here because I'm not dealing in the module right now. And there is a pin table that was really useful. Oh, this one. Pin description, yes. But we want to do it here. So Crystal DAC 21, 26. Okay, so we want 27 through 32 as well. Ivan, thanks for stopping by again. It's awesome to get your perspective on it because you clearly know this stuff really well. For those of you just listening in, Ivan says most, like 99% of boards by production volume, will use the standard pins, but who knows what folks may come up with. Yeah, it's totally true. I have to do like weird 3. Okay. All right, now we've got 30 through 38. And we basically want GPIO up through 45. Okay. Oh, we have a 46 on here. Is that not right? Oh, it is. Okay, so we want it through 46. And these I'm going to rename, so I'll just delete them. So we're going to do 40 through 44. And taking Duke's suggestion, we can do it real quick with this crazy multi-cursor stuff. I've always accidentally done it and it's never done what I want, but like I think you helped get my brain in the right like mindset for it. So that's awesome. Okay. And I think that's it. For this is the microcontroller pin module mapping. And there are 2 other places. Ooh, I could go crazy. There are 2 other places we're going to need a similar list like this. The externs and then the actual like struct definitions. But like I don't have the compiling to the point that compiling, like the compiler is not going to verify any of this right now. This is just like work I know I need to do for the future that I'll just knock out right now. Mark suggests Control E to jump to the end of the multi-cursor lines. All right, I think there's no other questions, and it's been just about 2 hours. So I'm ready to take a break, and I'll try to commit this and push it. But again, like hourly should get the linking stuff done as well. Like, we should be able to get to the point where we can actually communicate with the board, which is going to be a huge first step. And that's the step that we can actually get checked into the core CircuitPython repository as well. We'll have to set up the build CI stuff when we do that, so that because with CircuitPython we always create builds for every commit, because we verify that they all build, and we don't do a ton of onboard testing, but we at least make sure that everything builds and fits and stuff. So when we get the ESP32-S2 checked in, we're going to want to make sure that that's the case as well. It also means that it's really easy for people to test the latest versions, because when we do the CI builds, we push them to a bucket that Adafruit pays for. So you can just easily download the latest version of something of CircuitPython for a particular board that way. And so like getting through this initial hurdle of just like not even quite Blinky, but just like getting like math in the REPL working is a huge first step for folks. So yeah, I think let's call it. It's been kind of pinmuxing stuff. Fridays are weird, right? Like, you've been working all week and like the lower power stuff has sucked my life away. But just thank you to TAC, who does Tiny USB, found and fixed a really weird issue that we ran into with the low power stuff. So that was really helpful. So thanks again. Unexpected Maker says thanks as well. I need to catch up on your Feather Tester stream. I'm curious to hear where you are with all your stuff, and hopefully this stream was useful to give you an idea of what PR for supporting the Unexpected Maker boards would be. It's a very similar process, so hopefully that is clear for folks about how to organize everything. Yeah, thank you, everyone. I'm going to keep doing these streams Fridays, 2 p.m. Pacific. I live in Seattle, so that's how I think of it. I'm only usually posting about it the morning of, but I think it's safe to say that I'll keep doing it. And it'll be more like this format, which is any unboxings that I have that I could wait for. Then we'll do a recap of like whatever work I've done, and those recaps will be longer because hopefully I'll do more. And then we'll maybe do a little more work to get like just a little further, and those could end up being PRs, right? Like once we have this first, like it kind of works, and now I'm gonna do like maybe on a stream I'll do I2C or I'll do PWM or something like that. I know that one thing that Unexpected Maker was talking about was doing the NeoPixel stuff. NeoPixels will be a challenge and interesting, and also a priority for us, so that could be really interesting as well. Yeah, please support Adafruit, support Pololu, support local artists, local businesses, if you're lucky enough to do that. And Fred says, thanks. This is real soul of a new machine stuff, which is an awesome comparison. Thanks for that. Bruce has a Sala on the way, which is great. Geek Guy says thank you. Unexpected Maker says thank you, and that the first batch of the Feather S2s will be the re-release Feather S2s this weekend, which would be awesome. Are you going to stream that? Johnny says thanks for the extra subs. Congrats on 50K. That's awesome. I don't know if you saw my personal channel, but I think I'm at 6970. My personal channel is nothing but see all the things I watch. PE with Joe's really fun. 95 subscribers. I'm almost to 100. Obviously, I don't know why it says upload a video. I do have a few videos, but then again, I had the keys to the Adafruit Kingdom. So hopefully everyone enjoys the stream. I know that it's a lot longer than some others, but Unexpected Maker says no stream, but a build video would be cool. And Bruce says, new subs are very demanding about new content. Yeah. I don't do regular content, at least on my channel. There's some interesting heat visualizations though. But, all right, I'm out. Hope everyone stays safe, and thank you so much for joining in for all the different time zones and stuff. I really appreciate it. I will see you next Friday. If you want more content before then, I should say we have the Adafruit Discord server, which is adafru.it/discord. Would love to see you there. We chat all week about this stuff. There's an unexpected maker Discord as well that I'm in. You can ping me there. I have a lot of the channels for most Discords muted, so please, if there's something interesting to me, please at me, and I'll check it out and see it. And we also do have us, if you want more CircuitPython content, we do a weekly meeting with everyone who works on CircuitPython. That happens Mondays at 11 a.m. Pacific, which is 2 p.m. Eastern. And that's where you'll see kind of broader, get an idea for like how big the project really is. It's growing like a weed, and it's awesome. We're getting more awesome people involved. So if you're curious about CircuitPython, I highly recommend that meeting on Mondays as well. And then, of course, Adafruit has show and tells. We have a number of show and tells now. We have 2 on Wednesday, 1 on Thursday. The Thursday one is after John Park at 2:30. We have an hour long on Wednesdays with Phil and Lamore usually. And that's at 4 o'clock Pacific. This is what I know. And then we also have Ask an Engineer after that, which is always a good insight into what's happening with Adafruit. So I'm rambling. Have a good weekend, everybody, and I'll see you next week.